Excellent. Well, thanks and welcome along, everyone. Good afternoon or good evening, depending on where you are in the world, to this talk about Kubernetes cluster wrangling. So I think that we can all agree that Kubernetes and containers have been kind of a growing trend in the marketplace over the last 4 or 5 years now. And as more organizations start deploying large numbers of applications to Kubernetes clusters, we're starting to learn a bit about what can go wrong and what can go right. What are the sort of patterns that work to make secure environments with Kubernetes? And also, what are some of the things that we see the mistakes being made, right? Where can we kind of pick up those mistakes and kind of avoid them? So this talk is essentially based on my experience looking at Kubernetes for a while now, and I want to talk a bit about some of these challenges that you will have if you're using Kubernetes, and then some of the ways I think you can address them as well. And we're going to look for trying to make Kubernetes clusters secure and usable because that's important too. Before I get started, very brief about me, a little bit of background. So yeah, as Matt said, my background is information and IT security. I've been doing that for about 20 years now. I'm an ex-OWASP chapter leader. Back when I lived in Edinburgh, I was the OWASP Scotland chapter leader for a couple of years. I am a cloud native security advocate for Aqua, which basically means my job is to educate and inform around containers, cloud native security. As Matt mentioned, I have helped been authoring the CIS benchmarks for Docker and Kubernetes. And if you're looking for like specific hardening guidance, like which exact flag to turn to which exact value, those are great places to start. We're going to be talking about some higher level stuff today, but those are also good guides to look at as well. I'm also a member of Kubernetes SIG Security. For those of you who haven't involved yourself a lot with the Kubernetes project, they're arranged into special interest groups, and I'm involved in the security one. If, maybe after this talk, you think Kubernetes security is something I would like to learn a lot more about, then, we're a very welcoming group, meets every week, every other week, and you can just come along and listen or participate. There's also groups that look at security documentation and security tooling. If you've got any questions after the talk, there is my Twitter handle and my email address. Please feel free to drop a line, or if you're not going to ask it at the end of the talk, something kind of crops up the next day or two, or whatever. As you might have guessed by my accent, I'm not from the USA. I'm actually based here. This is Loch Goil Head in the West Scottish Highlands, which, as you can see, looks very nice on a sunny, dry day. If any of you have ever been to the West Highlands of Scotland, you'll know that unfortunately we don't get a lot of those. So I always try and take pictures when it looks like this. Anyway, let's get on with the talk. So we want to talk about Kubernetes, and we want to talk about securing Kubernetes. To do that, the first thing we have to define is, what are we talking about with Kubernetes? One of the big challenges with this field and with securing this field is all of the different ways that you can make use of something which is Kubernetes. The way that the project works is they have a list of certified distributions. These are distributions, software products, services, could be service, software as a service, could be platform as a service, could be an open source project. Anything which is conformant to Kubernetes can be one of the Kubernetes distributions. However, from a security standpoint, quite a lot of times they'll do things differently. So if someone asks me a question, what's Kubernetes default for securing X? I'll generally ask, which distribution are you talking about? Because they could be different. If you look at something here like OpenShift, OpenShift's very opinionated and it has a lot of additional things built into the platform. So it's got a very particular way of handling it. And that's likely to be different from Tanzu, which is VMware's Kubernetes, or EKS, which is Amazon's managed Kubernetes, or any of the other ones, Rancher down here. There's all sorts. So the first thing that we have to concern ourselves with is can be quite difficult, and this is a challenge you'll have, is exactly which Kubernetes are we talking about. However, what we can do is we can think about core Kubernetes. In order to be a Kubernetes distribution, in order to be a considered a conformant one, you have to have certain features, certain functions. So this is what a Kubernetes cluster, the basic version, looks like. And all of them pretty much work this way. So the way it works is we have two sets of nodes. Those nodes are typically virtual machines, could be physical servers as well. We've got our control plane nodes. And our control plane nodes are how we manage the cluster. The core service, the thing that's most important to us in terms of the security of the platform, is the API server. The API server is a REST API. So, coming from a web app background as we are, it's quite interesting to know this is just a REST web service. You can handle, you can talk to it via curl. You don't have to use the tooling, and everything pretty much it does is just curl commands. So it's quite easy to manage from that perspective, or at least easy to get started with. But the API server is our most important component from a security standpoint. If an attacker can compromise the API server, they can pretty much compromise the entire cluster every single time, and they're going to be able to compromise every machine in that environment. So those are our control plane nodes. And then we've got a set of worker nodes. And our worker nodes are where our applications are deployed. So the way Kubernetes works is it has a set of virtual machines or physical servers, and you deploy containers to those virtual machines or physical servers, and they run on the worker nodes. The important components for this, our kind of talk today, is one, we've got this thing down here called container engine. Traditionally, this would be Docker. So Docker would be the container engine that most cases would be what's used, but it doesn't have to be Docker. It can be anything which fulfills what Kubernetes calls the container runtime interface. So anything which has those properties. Could be CRI-O, which is Red Hat's container engine. It could be containerd. And indeed, in modern clusters, it's quite likely to be containerd. It could be Docker, or it could be other things. There's other ways of doing it as well. But something which runs containers has to be in our cluster, because that's what it needs to actually operate and make things run. Then the other thing we need here is we need something to sit between our container engine and our API server. And for that, we have a thing called the kubelet. So the kubelet essentially takes commands from the API server, passes them to the container engine. Now, I've got three components here in red: the kubelet, the API server, and etcd. And these are the main security ones we need to concern ourselves with, because compromise of any of those typically is very bad news for the cluster security. etcd is the last one I haven't mentioned, and that is a fairly simple key value store database. Kubernetes by default is ephemeral. It doesn't store state, so it needs some external data store. And in almost all clusters, it doesn't have to be etcd, but pretty much every major distribution uses etcd. So a compromise of that will also cause us security problems. All three of these have got a network attack surface. So there is a port, there's a service. The kubelet and API server are just HTTP. The etcd server is a gRPC, so it's kind of HTTP2 with some binary serialization. But those are all services that can be attacked by attackers. So that's our basic Kubernetes. Pretty much all Kubernetes will work like this. We'll try and focus, I think, on the kind of core of it. We won't go too much into how 137 different services work, otherwise we'll be here for a very long time. So why is it important? Why do I think that architecting clusters securely is such an important thing? Well, Kubernetes is growing in popularity. Lots of organizations are making use of this. It's only, the last 3-4 years has been huge. From early day adopter days, it was only about 3 or 4 years ago. We're now seeing across many different industries, financial services, public sector, and pretty much every other industry out there, there's pretty heavy additional use of Kubernetes. So trying to secure Kubernetes platforms becomes ever more important. This one's a kind of important one as well. Kubernetes is what I call distributed remote command execution as a service by design. That's what it does. Containers are just Linux processes, and Kubernetes lets you run these things on lots and lots of machines. Well, what's running a process? Well, it's command execution. So what is Kubernetes? Well, it's distributed remote command execution as a service. What that means is if we have a problem with the security of our clusters, it's going to be quite serious, because it's going to give attackers a lot of power if they can misuse our Kubernetes clusters. So the security of them is important. And then the other thing that's important in terms of getting the architecture right and in terms of doing this kind of work to create a secure platform for our developers is that Kubernetes security can be complex. What you'll probably see as we go through this talk is there's a lot of, as Matt mentioned, there's lots of different knobs and dials, lots of different things you can change. And knowing how all of the work is fundamentally fairly tricky. So it's important to put thought into this early on. Now, the title of the talk is making clusters secure and usable. So where does usability come into this equation? And the answer to that is, this is Avi Duglin, who actually just is now a board-elect member of OWASP. This is Avi's maximum of security, which I kind of quote quite a lot. Security at the expense of usability comes at the expense of security. And to me, what that means is anytime I've seen a security control that's not usable, that users find very awkward or hard to use, they'll bypass it. Simple as that. If you think about how passwords work, if we make passwords long, complex, don't let people write them down and make them change them every 30 days, they're going to find some way around that. They will make a sequence password, password 1, password 2, password 3. They'll do something to bypass it because that's unusable security. Users don't like doing that, so they will find a way past it. So it's important when we're doing security architecture for Kubernetes that we try and make things usable for our users. In this case, our users are application developers, developers who want to deploy their applications to Kubernetes clusters. We got to try and make their life, make it easy for it to be secure rather than making it hard. Otherwise, people will just bypass the security teams. So let's talk about some challenges. Let's talk about some of the things that can go wrong. The first challenge we could have is our clusters being exposed on the internet. This is there's a search engine called Census, which kind of looks like Shodan. Shodan's maybe more popular, but I've used Census for this because it's got a lot of good information. One of the things that's quite interesting to note about Kubernetes API servers is they have distinctive information in their TLS certificates. You can always spot a Kubernetes API server based on the names that the certificate has got. So what this is a little search, which looks for the name kubernetes.default.service.cluster.local. Pretty much every API server of every Kubernetes distribution will have that name in the API server certificate. And if we look at those online, we can see that there's about 900,000 clusters online directly on the internet. Now, this is not great from a security standpoint because one misconfiguration in that API server and an attacker has got access to that remote command execution as a service, right? It's a dangerous thing in Kubernetes. If you get it wrong, people can do bad things to your clusters. There's 900,000 clusters on the internet. So that's not great. In addition to that, there's actually, I think about 100,000 kubelets directly on the internet and about 5,000 etcd servers. Not quite as common, but still, all of those three are quite dangerous services. It's something I've noticed that there's quite a lot of people putting them directly on the internet. And these are spread amongst the major cloud providers. It's not just one provider who's got this kind of thing going on. So that's a challenge for us. You know, we've got this default position where these clusters are exposed. And the other thing that's worth knowing about is we can actually prove that this misconfiguration, that we have problems with this. Because Census, rather interestingly to my mind anyway, they actually will query Kubernetes clusters that are online, and they will try and use an unauthenticated query to pull back all the information out of the cluster, which only works if the cluster has been horribly misconfigured. And whilst there's not a huge number at the point in time I did this query, there's still 674 clusters sitting there allowing remote users to, essentially list pods. And that probably means you can do anything you want on those clusters. So we've got a problem with exposed clusters, I think. How do we solve that problem? Well, I'm going to focus on the main three cloud Kubernetes clusters: GKE, Google's; EKS is Amazon; AKS is Azure. In all three cases, the default position for an API server created with their managed clusters is to put it online on the internet. So if you don't do any changes in configuration, it's going to be there on the internet. And it's going to be a situation where one serious configuration error or one set of lost credentials could end a very bad day. However, all three of these clusters provide the alternative options of having private clusters, don't put it on the internet at all, or having authorized networks, so restricting where you can do that. So the first thing I would say is definitely worth doing: go through all your Kubernetes clusters and make sure that they are using those options. Make sure that private clusters is enabled, make sure that authorized networks, if you can't make it private, at the very least, restrict it to whitelisted authorized networks for access. I don't really think there's a huge number of reasons why you want to put Kubernetes directly on the internet. I've heard some people talk about SaaS monitoring services, but with that, you should be able to do source IP address filtering, something to stop this, because otherwise things can go kind of fairly badly wrong. So that's our first challenge. Our second challenge is outdated clusters. So needless to say, Kubernetes, like everything else, has CVEs. You have to keep it patched. And the other thing about Kubernetes is it has quite a short support lifecycle. Until this year, the support lifecycle was 9 months. So if your cluster was more than 9 months old, it was going to be not getting security fixes anymore. That's extended to 12 months. And some Kubernetes distributions will give you a bit of extra time, maybe as much as 2 years, but that's the absolute max. And you can't always rely on it. Some of them are quite short. So the question is, do we have a problem with outdated clusters? Do we have a problem with people not patching their clusters, not maintaining them? Well, we can actually find that information out, again, thanks to a handy census query. There's an interesting configuration choice, which a lot of these cloud distributions make, which is they will expose certain endpoints on your API server without authentication by default. It's a Kubernetes default, and some of the major cloud providers will keep that default. What that means is you can actually query a lot of Kubernetes clusters, and you can say, give me the version information that's running, so you can find out whether they're outdated or not. And it comes back with about 79,000, so just under 10% of clusters have this option enabled. And so we can assess the problem. And it turns out at the moment, so considering that Kubernetes is a relatively young piece of software, a lot of people haven't been using it very long, we're already at 25% of clusters running unsupported versions. So that means if there is an ODE tomorrow in the Kubernetes API server, 25% of clusters are going to need to upgrade like 3 versions, 4 versions plus at once, which is likely to be pretty disruptive. That's the kind of thing that you know, your workloads of the Kubernetes API can change quite a bit from version to version. Doing 4 version upgrades at once is quite likely to cause problems. So we can say that there's a problem here already with clusters essentially falling out of support. So how do you fix that? This is my feeling for how the best way to fix this is clusters should be cattle, not pets. We've kind of heard this idea that applications should be cattle, not pets. So I should be able to redeploy applications. I shouldn't have pet applications that I can't reboot. Clusters should be the same way. So what I mean here is you should be able to automatically reprovision your clusters to roll them out. And you should be regularly practicing re-rolling out a cluster, migrating the applications from one to another, and draining down the old cluster. Because you need to be able to keep doing this on a regular basis. It needs to be part of your practice. And the best way to do that is not to have pet clusters, not to have clusters where you don't know what's going to happen if they get something, if they crashed. What would happen? You need your clusters to be cattle, to be redeployable. It's an extension of the infrastructure as code idea, is to have this kind of situation where you can essentially recover automatically. And I think that will help, because once you've got that position, it's not scary anymore to do those upgrades, and you can keep rolling up with each latest Kubernetes version, which is going to be a lot smoother path than waiting some time until it's out of support and then waiting for like a bad CVE to come along. So the next challenge, we've talked about our exposed clusters and our outdated clusters. The next challenge is the first of the things that the Kubernetes project has made conscious decisions not to handle certain security problems. They've decided to make those essentially a third-party issue. They don't want to concern themselves with it. And the first one really is authentication. So Kubernetes provides some inbuilt authentication options. It is a multi-user platform, but none of the inbuilt authentication options are suitable for user authentication, not suitable for production use. So none of them make sense or should be used in production. The first one is token authentication. That stores things in clear text on the API server, and you have to reboot the API server to make a change to your credentials. Fairly obvious that isn't suitable for production. The second one that's far more commonly used is client certificate authentication. So you can use client certs. Now this sounds great, right? Client cert, we use client cert authentication quite a bit. But in Kubernetes, it should never be used for user authentication, and I'll explain why. There's no certificate revocation. You cannot revoke a Kubernetes client certificate. If you lose the certificate, then the only way to mitigate it is either destroy the entire cluster and rebuild it, or essentially rotate the keys of the entire certificate authority, which is almost as bad, frankly, as re-rolling the entire cluster. You might as well re-roll the cluster at that point. So client certificates should never be used. And these are the 2 inbuilt options. And that lack of revocation is a long-standing issue in Kubernetes. There's a GitHub issue, which you can go look at. It's about 5 years old now. The other thing to note about client certificate authentication is it is, whilst I'm saying don't use it for ordinary users, you will often find that you get kind of like a first user. So when you start your cluster up, you install the software or you install the service, you'll get given a first user. And that first user will be a cluster admin user, because you need like an initial user. But it uses the hard-coded system masters group in a lot of cases. And when I say hard-coded, what I mean is that the rights of this group are coded into the Kubernetes API server source code. So even if you remove every RBAC rule out of your cluster, this will still work. And that's kind of by design, because it's a break class user. The problem I've seen with this is that quite a lot of administrators will use these certificates for day-to-day admin, which is obviously not a great idea, especially if you can't ever revoke the certificate and your cluster is on the internet. because that's not a great situation. And yeah, in general, you see this quite a bit in different distributions. It's not uncommon to see system masters, but from a security standpoint, best to avoid it. To give you a very quick demo, just to kind of show what that looks like, and also to make sure my demos are working, let's run this. What I'm going to do is just, the way that the Kubernetes certificates work is they're encoded in a file called kubeconfig, which is just your credentials. But we can extract that out and have a little look at it. So this command here, I'm just going to extract my config, and I'm going to get the client certificate data. I'm going to pipe it through base64, and then I'm just going to decode it through OpenSSL. And I'm copy pasting that because I would have made typos if I tried to type it out. And what you can see is this is the way a Kubernetes client certificate works. Here, this is my default user. So the way they work it is they put the group information in the O field of certificate, which is a bit weird, but that's how it works. And then the username is this. And as you can see, that's a generic user. So this is a generic user with a hard-coded group, and you can't revoke it. And the lifetime is a year. That's pretty typical, about a year. So in general, managing those client certificates is kind of an important point. You don't want to lose those. You want to put them away somewhere safely as soon as the cluster is created and never use them. So that's what I'm like about. So how do we fix this? That's like a technical thing, which is don't use the client certificates, but what's the user, what do we do for user authentication then? And the answer essentially has to be that when you're architecting your Kubernetes platforms, you need to account for there to be some kind of external authentication service. If you're using cloud managed Kubernetes, so GKE, AKS, EKS, whatever else, Cloud IAM is almost inevitably the best way to handle this. All of those clouds, all of those Kubernetes cluster types will merge in with Cloud IAM. So you can use your existing Azure AD or your GCP users or your AWS users and do it that way. So that would be definitely my recommendation if available, because the integration is fairly easy. If you're using unmanaged Kubernetes or you're doing on-premises, then you'll need another piece of software. So this would typically be something like Keycloak or Dex, and those are OIDC servers that sit between your cluster and an LDAP store, something like Active Directory. And basically, when you're architecting your platforms, when you're looking at how you use Kubernetes, you need to factor in the fact that you're going to need to deploy something here. Because as I said, you don't want to leave groups of developers without any good authentication option, because they'll start using client certificates. And client certificates are not a good idea. So that's authentication. The next thing to consider about or to think about when you're architecting your Kubernetes environments is the complexity of RBAC. So Kubernetes for authorization uses an inbuilt thing called RBAC, or role-based access control. It's got what I'll call a lot of things in Kubernetes are very flexible. That's one of its kind of like good points and bad points, right? It's good points because you can do lots of different things with Kubernetes. Bad points are that the complexity shows itself with the flexibility. The more flexible it is, the more different things you can do, the harder it can be to work out exactly what's going on. And RBAC is no exception. Kubernetes RBAC, there's quite a lot of privilege escalation options. There's things you can grant which don't sound sensitive, but turn out to be quite sensitive. There was a good example of this last year, CVE 2020-8554. And that was a vulnerability where any user who could create a service object, which is quite a common type of object in Kubernetes, could intercept traffic from other users of the cluster due to the way that the service object was set up. So you might not realize that when you're just creating these things. An important point about that CVE is there is no patch. You have to mitigate it. And one of the mitigations is don't give people the right to create services unless you really need to. So there's lots of different kind of pieces of flexibility in RBAC. In general, it's a tricky one to get right. And I'm going to kind of demo one just to kind of show another one. Because this one's one of these things that's kind of somewhat unintuitive. And this is why I say it's complex and something you probably want to try and avoid using too much. So what I'm going to do for this, what I've done here is I have got a user in this cluster called secret lister. So we've got standard Kubernetes cluster, and this user, if you look at what they can do, so this Kubernetes command just says kubectl, and it says, can I list? Let's just list the rights of a user. And down the bottom, let me just hit enter so it pops up a little bit. We can see that the only right I've really got here is I've got the right to do list secrets. So this user, all this user can do is list secrets. These other things are just like things like being able to get the version endpoint, but this user doesn't have any other rights. So what I should be able to do is I should be able to list secrets. Great, that works. So that's, you think, okay, that's working as intended. What I don't have is the right to get secrets. So get is a different verb in Kubernetes API. So I can list them, but I can't get them. And we can prove that that works as expected by doing that. And it says, no, go away. This user cannot get the resource secrets in the API group default. So far, our back sounds quite straightforward. We've given someone the right to list secrets, but we haven't given them the right to get secrets. Okay, sounds great. What happens if I do that list command again, so get all the secrets, but I just tell it to output YAML data instead of outputting just like the standard text data? The answer is I get the contents of all the secrets. Because whilst list sounds like list, the way the Kubernetes API works is it actually returns the contents of all the secrets when you do a list operation. It's just usually you can't see it. This is kind of an example of the kind of things that can cause you problems in RBAC. This is one of many kind of little niche edge cases that is tricky to know about. That particular one can trip you up because you think you're giving someone the right to list secrets. You don't realize you're actually giving them the right to get all secrets. And with those secrets, typically you can escalate privileges quite easily. So what's the answer to this? My general answer to this in terms of architecture, architecting a secure Kubernetes platform, is try to not give developers direct access to the Kubernetes API where possible. And that kind of helps mitigate the authentication issue as well. The fewer people you've got with direct access, the less of a problem you're going to have with these two places. I've got the idea here you would use something like maybe like Jenkins. So you get developers to push things via CI/CD, and then the CI/CD tool deploys to the cluster. That could also be something like a platform as a service, where you give the users a web portal, they log into the web portal, and they have like a form to fill in or something like that. That's the kind of thing that OpenShift does actually, where a developer can deploy without directly needing to play with the API server. This obviously moves the problem a little bit to the other thing you've used, so you're moving to a CI/CD system. But because Kubernetes RBAC is complex and easy to make mistakes, and because Kubernetes authentication, if you don't want to add on an external service, is kind of hard to do. I personally think this is a better way of doing it. Try and keep developer groups away from directly hitting the Kubernetes API server. So what's our next challenge? Our next challenge is flat networks. When you deploy a Kubernetes cluster, you may have 10, 100, even 1,000 applications running in your cluster. By default, every Kubernetes distribution pretty much will put them on a big flat LAN. So any container can talk to any other container at any time they want. And this has got a couple of problems. One, obviously, it means the attack surface for a compromised container attack. So if an attacker accesses one container, they can go anywhere they want. The other problem is something I noticed from my pen testing days, which is that quite a lot of this software you might deploy, kind of supporting software, monitoring, logging tools, things like that. They often assume that the container network is trusted. So they will make this assumption that, hey, well, I'm on this kind of private network, this container network. I don't need to worry about security. And there's been many examples of that. There was a good example for Prometheus, which is a common container monitoring tool, or Kubernetes monitoring tool. And their documentation, definitely last time I looked at it, said that if you wanted authentication, well, that wasn't their problem. They weren't going to do authentication. They didn't feel the need for it. You needed an external authentication service. And that's not an uncommon attitude. There are quite a few people who think, well, my software is deployed inside the cluster container network. I don't need to worry about security. So having these flat networks is a bad idea. And there's another reason why it's a bad idea, which we're going to do in the demo, just to explain how this works. So Kubernetes has this concept of service discovery, right? You're meant to be able to, it's one of its features. So if I was, let's just say for the sake of, I'm going to run a little container here. Let's say I was an attacker and I had compromised one pod, one container, one application running in a cluster, and I got a shell, which is what I'm going to do now. I'm just going to run essentially a container into this cluster. And once it's running, it should give me a shell. And that's essentially emulating what a compromised container attack would look like. That's where I find out that Docker Hub has crashed and my container pool is not going to work. No, it did. Okay, we're working. Excellent. So I've got access to one container. My first step as an attacker is probably going to be what else do I find? Now that could be quite noisy. Attackers might think, oh, I don't really want to port scan every single port on every single IP because it's going to be noticed. The good thing about Kubernetes is you don't actually need to do that. You just do this. What I'm doing here is I'm using dig DNS lookup command, and I'm just going to ask it for server records. And I'm going to give it the name any service cluster local. And it happily tells me about every single service running in this cluster. It tells me what the service name is, it tells me what the namespace is, and it tells me what port it's running on as well. So it's very easy to get access on this flat network, to find out what services are running, and then to try and attack them. So you can actually, once you've got that information as an attacker, then you can just say, right, I'm going to hit port 80 on this sock shop app, and I've got nmap, and away you go. So this is why I'm saying in terms of the flat network, it's very good to get rid of that because it's very easy to do this kind of service discovery and to make attackers' lives easier. Now, from a security architecture point of view, obviously we're trying to make our attackers' lives harder. We're trying to make it more difficult for them to, get a foothold and then leverage and break out. I think actually an easy, I think actually when I was researching these slides, I realized that you could take that output and make it a bit more useful. So I wrote that, and that just creates an nmap command that will scan every single service in the cluster on all the ports they are listing on. So it's very useful. It's a very useful feature, but it's also unfortunately quite good for attackers because it gives them all that information they want in a really easy to get to format. So how do we fix this? How do we, from a security architecture standpoint, how do we resolve this problem? And the answer's got to be default deny networks. Kubernetes ships with a feature called network policy, and network policy can be used to provide a kind of a default deny situation, a default deny setup. It does mean that we need to work with developers. This is one where I've not seen a great solution for automating it, but basically early in the development lifecycle, a question that needs to be asked if you're going to be deploying to Kubernetes is, what other things do you need to talk to? If you're writing a web app, what databases do you need to talk to? What other APIs do you need to talk to? And those policies need to be developed early in the development lifecycle. What you don't want to get into is security teams, retrofitting network policies after things have gone into production. So I think that one is kind of necessary to kind of look at from that perspective. It's one that's really an education one. There's not a great technical fix there, I don't think. The other thing you worth knowing about, though, is that there are some better ways of doing network policy. Kubernetes-based facilities are quite basic. But if you're using certain CNI, certain network providers like Cilium or Calico, they've got additional features that you can add on as well. So we've talked about networking breakouts, right? We've talked about the fact that a network, this big flat network, is good for attackers, but not great for defenders, and that we need to change it. The other thing we need to worry about is breakout to the underlying nodes. Kubernetes runs Docker containers. Docker containers fundamentally are just processes. And Docker has what I've always liked to call a flexible security model. So Docker was a tool that came out of the development world, and it also assumes that if you're allowed to run Docker commands, you can remove all the security, all the isolation that it provides. Kubernetes essentially builds on top of that, and by default, if you don't have any additional security in your cluster, Kubernetes kind of assumes the same thing. It says, if you have the right to create containers in the cluster, you can just remove all the isolation. And that's not, again, that's not good from a security standpoint. So it's something we need to account for, because the default posture of pretty much every cluster, if you don't add on additional security controls, is going to be that anyone who can create containers can get access to the underlying nodes. The only one I think is the exception to that will be OpenShift, which I think ships with default policies that will block it. But most of the rest Kubernetes clusters don't do that. So hold on. So what does that look like, right? I've said, we can break out the underlying node. Is it some super complex hacky procedure, or is it actually quite easy? So we should demonstrate that. So to do that, I think I want to change, let me change clusters. So I've got a little blank cluster here. There's nothing running in it. It's a fairly basic kind of single cluster. And what I'm going to do is I'm going to create a manifest. So I'm just going to create a manifest inside the cluster. and it's decided did this to me the other day. Hang on, I'm going to retype this particular command because for some reason I can't spell it. It doesn't want to do it. When I retype it, I'm going to retype the whole command. Hey, and it works fine. There we go. So what I've just done is I've just created a pod inside the cluster, very basic pod, and we can have a little look and see what it looks like while it's spinning up. Okay, this is a very basic pod manifest, and what we can see is we are doing certain things. However, so this is just a pod. Anyone who can create pods can use this. It's going to give us host IPC, host PID, and host network. So these are all Docker security layers that we're basically just saying, hey, could you turn off that isolation, please? I'd like to see the host resources. And it's also going to give us privileged true. Privileged essentially is, I don't want any security. Can you please remove it all? But Kubernetes will let you set that because you might want to. And if you haven't told it not to, it's going to let it work. So whilst I was talking, hopefully my pod has been created. Yeah, we've got that running. And what we can do now is we can just do this command here. And what this command here is basically saying is it's going to execute a command inside a running container. Now, an important thing to note, and something which I think can trip people up, is I could be anywhere in the world, right? My client could be in one place, my server's in the other side of the world, and this will work just fine. To get command execution on a Kubernetes cluster, you don't need SSH, you don't need anything else, you just need Kubernetes API, because we'll show you. Before I run this command, I am the root user, but I'm on my workstation. I'm on the sapling, which is the name of this little VM that I'm running in. Once I hit enter, I'm now the root user on the cluster control plane, right? That simple. Run the pod, execute the command root/host, and away you go. And I'm suddenly I'm root inside the cluster. And I'm real root, so I can go into etc Kubernetes PKI, where all the really sensitive files live. And I can get this here. This is the certificate authority private key for this cluster. With access to this file, I can create new cluster admin users, and it lasts for about 5 years. So this is essentially a backdoor into the cluster if you get access to those files. And by default, anyone who can create pods can get access to those files because Kubernetes lets them do it. So that's not great. The interesting thing is, obviously that wasn't super elite. That wasn't some amazing hacking technique. But in recent versions of Kubernetes, it's got even easier because Kubernetes has a great feature called kubectl debug. Kubectl debug, basically, you just tell it what node you want to debug, and you tell it what image you want to use. I'm just using a blank BusyBox image. And it says, great. And what it does, if I type in the command root/host, it does the exact same thing my manifest did. This is now a piece of official Kubernetes functionality. If you want to get root access to a cluster node, you can just debug the node. And if people have got the rights to create pods and there's no additional security controls in place, this will work just fine. So that doesn't sound great, not something we want to have. If you're doing security architecture for Kubernetes clusters, you need to block this. How do we do that? The answer is admission control. Up till Kubernetes 1.21, there was a feature, or there still is a feature, but it's deprecated now, called pod security policy. And pod security policy was basically designed to block exactly that. It was a thing that you could use to restrict groups of users and say, you can't do privileged containers, you can't do host network containers. However, the Kubernetes project has deprecated that. They basically said it was a bit of an awkward feature to use, so it's been deprecated, and it's going to be removed in like a version or two's time. There's going to be a replacement in tree, so within the Kubernetes project, but it's very basic by design. It's not designed for complex use cases, probably won't do for any complex use cases. So what you need to do is look outside to the external world and say, what else can I get here to add in? If you've got a commercial container security solution, they will do admission control, or they definitely should. In the open source world, we have got Oppa Gatekeeper, we've got Kyverno, we've got JS Policy, and we have got KubeWarden. Each of these has got its own strengths. The two biggest ones are Oppa Gatekeeper. This is a generic policy engine, which happens to cover Kubernetes. It does lots of other things as well. So if you're looking for a generic policy engine, you're looking for something which can, essentially do security policy work across many different services, Opera is a great place to look. Kyverno is focused purely on Kubernetes, so it just does Kubernetes. And its rules are written in YAML, which if you're doing Kubernetes, you're probably quite familiar with. You will be quite familiar with writing YAML, whether you want to be or not. So it's not a bad option if you're looking to focus purely on Kubernetes. Opera uses its own language called Rego to write rules, which can be a bit tricky to get used to. Two newer ones which come up this year, JS Policy. You write your admission control rules in JavaScript. So if you're a JavaScript house and you're super great with JavaScript, maybe that's a good option. And then Kubewarden uses WASM, uses WebAssembly. So if you want to write admission control rules, you can use WebAssembly, which means you can use things like Rust. Those are both kind of newer projects though. But the key point for this is you do need something for admission control. It is something if you're doing Kubernetes in any kind of large scale, you need some kind of external admission control. So the last of the challenges that I want to talk about is multi-tenancy. A lot of people debate to get the best benefit from a financial standpoint from Kubernetes clusters is to run multi-tenancy, right? Is to run 10, 100, 1,000 applications. That's where you get the best bang for your buck. You're saving the most money. But Kubernetes isn't really designed for multi-tenancy. We've already seen some ways in which it's not designed for multi-tenancy. So DNS is cluster-wide. You know, that command I ran a couple of slides ago, which gave me a list of every service running in the cluster, is because DNS is cluster-wide, and it's critical to the way Kubernetes operates. So that's a first challenge. There's also some object types in Kubernetes that are cluster-wide. So you can't give rights to a group of developers, you know, who may only have one namespace. You can't say to them, hey, you can do this. And the main one is they're called CRDs, custom resource definitions. Those are cluster-wide as well. And that means that if you've got one group of developers who want to put in a third-party product, you can't have another group of developers with a different version of the same third-party product because it uses the same CRD. You can't have two different versions of the same CRD in a cluster at the same time because they're cluster-wide. So that's another area where there's a problem. Again, network plugins often are not designed for multi-tenancy. So if you think about, maybe you wanted to say, oh, I'll give these developers like 5 machines, and those are dedicated to them. So if they break out to the underlying node, it's not a big problem. The challenge here is that network plugins may not be designed for multi-tenancy as well. So it might, you may be able to get more access that way. And for the last demo of the day, I'm going to show you another place. This is a recent CVE that came up, which takes advantage of Ingress. And Ingress is essentially, Ingress is like a reverse proxy. So it's the way you get traffic into a cluster if you use Ingress. And the way this CVE worked is that there's an Ingress controller called the Nginx Ingress controller. So essentially it's Nginx acting as a reverse proxy to get traffic into your cluster. Let me get my screen up here. And the way it works is you have one of these things, an Nginx Ingress controller that sits at the cluster level. This is something you would deploy with your cluster. And then what you do is you give each individual set of developers the rights to create an Ingress object. So they create an Ingress object, which is just in their namespace, that makes use of the cluster-wide controller. The CVE came because basically at a namespace level, you could rewrite the configuration of the cluster-wide object. And you were able to do something like this, which essentially said define a new website in my reverse proxy and expose the service account token, which essentially is the credential that the cluster-wide object used. So this CVE was quite nasty because it meant that anyone who had one namespace access could have access to the cluster level resource. And if you did that, it ended up looking like, like that. And essentially at that point, that there is the token that would give you access as the same access as the entire cluster level Nginx Ingress resource had. And as it happens, that's got get secrets at a cluster level. So it's going to be cluster admin. This is just to give you an example, to give you kind of another example to the ones I mentioned, that when I'm saying that it's not designed for multi-tenancy use, definitely if you're trying to do hard multi-tenancy, I would be very careful before I try to do hard multi-tenancy with Kubernetes. A lot of companies like to do it because I said it's great for saving money, but Kubernetes fundamentally has quite a lot of places where that's not been designed for that to work. So Cluster API is a solution to that. Basically, I think you've seen from a couple of things I've said, I typically regard the cluster as a security boundary. And so the best way to do this is to give people each their own cluster. Cluster API lets you create clusters via the Kubernetes API. So you can actually create its own clusters like child clusters. So that's quite a good technique to deploy to look at cluster API and say, can I maybe use this to automate the creation of clusters, giving each development or each team their own cluster. So to bring it all together, what does a secure Kubernetes solution look like? It's just my opinion, but this kind of builds up on these challenges and how you solve them. If you're architecting Kubernetes clusters, you need to abstract the underlying clusters from developers and application owners. Try not to give people direct access to the Kubernetes API, and try and give the developers or groups of development teams templates that implement good practice. So things like starter network policies, things like setting good security options so that your mandated policies don't cause problems are a good place to start. Fully automatic clustered creation and destruction. This is getting easier because Cluster API hit version 1.0 recently, and so you've got a programmatic way to create and destroy clusters. And combining that with infrastructure as code, so combining it with the way you kind of create templates and YAML, can give you this facility to have fully automated cluster creation and destruction. And then inbuilt security controls. When you're designing Kubernetes platforms for groups of developers, it's important to get these in place before people start deploying applications. So having admission control with a decent set of rules that stops people just breaking out to the underlying node, having default deny networking in place prior to applications being deployed, because obviously, as anyone who's ever done firewalls knows, retrofitting firewall rules is a huge pain. And then doing things like container image security as well. So making sure people can't run random images off Docker Hub is always a good one to add in. But all of these are best built in at the platform level, ideally before a lot of applications get pushed onto the clusters. And then, embedding controls in template manifests. Everything is described as code. We can embed the controls into the manifests and then give people and say, look, there's a template, drop it, fill in the blanks essentially with your application. One thing you've probably noticed about this, and I'm sure some people are going, what, in the audience, is this does require a platform management team to know about this stuff. Whilst I think we can create a usable Kubernetes environment from a developer standpoint by doing all this and having these guardrails, it does mean there's a level of complexity that either has to be handled by the platform team or by some software as a service. If you're getting something which it could do quite a bit of this for you, but somewhere that needs to get done. So in conclusion, what hopefully you kind of grasped from this talk, if anything, is Kubernetes is not a complete security solution on its own. That's deliberate. That's the project have designed it that way. They're not trying to create a complete platform. It does need additional components for secure design. You're going to need to consider when you're employing it. You can't just put Kubernetes in and have it run. Otherwise, you're not going to have a very secure solution. You need external authentication. You need external networking support for good network policies. And you also need admission control, amongst other things. And ideally, it's critical to consider the security requirements as early in the design process as possible. I've seen quite a lot of clusters, and I've seen how hard it is to retrofit security controls into clusters once you've got 100 applications running there. So ideally, in an ideal world, get that done early, get all those things put out, and that should make things hopefully less painful for your developers when they're deploying to clusters. So that's the slides.